Hey everybody, welcome back. I'm going to try to talk a little lighter. I know the recordings are a little loud, but you can always adjust your volume as well. So here we are, we have 91 AB6. This is an AP question. Now the idea of this is not for you to just watch the video straight through and think you're going to learn it. Try the problem, work on the problem, and then come back and see if you're doing it the way or getting the same answers or solutions that I am. So we have this situation on 91 AB6. A tightrope is stretched 30 feet above the ground. So there's my tightrope between the Gallup and Ripley buildings, which are 50 feet apart. So that's 50 feet apart. That's where that is right there. A tightrope walker walking at a constant rate of 2 feet per second. So the tightrope walker is walking across the tightrope at 2 feet per second from point A to point B is illuminated by a spotlight, which is up here G, right directly at point A, as shown in the diagram. So here's the diagram, you see that. Part A is how fast the shadow of the tight walker's feet moving along the ground when she is midway between the buildings. Indicate units of measure. Okay, well before we do that, I'm going to label my diagram a little bit. So you might look at this and think, okay, I see triangle. So you might think Pythagorean theorem, or you might think what that other triangle one, what was that other one? Let's do it in some trade. There's no angle given, there's no mention of an angle given, there's no theta, there's nothing like that. So trig is probably out. Could we do something with Pythagorean theorem? Well, this is a spotlight, mind you. This is light. I don't know if we're measuring light, so we're not going to have a hypotenuse, so we might have to use something else. Well, there's something else here that is kind of neat. It is this triangle and this triangle. And these two triangles are known as, from your geometry, similar triangles by the AA postulate. AA because the angles right there are congruent, and then this angle is the same. It's shared by both triangles. So the AA postulate of similarity. So they're similar. So you should remember something, or if you don't, we'll talk about it. The sides of similar triangles have a specific special relationship. Do you remember what that relationship is? Or they're proportional to one another. So you'll see us set up some ratios later on. So I'm going to erase that since, whoops, I'm going to erase all that. Uh-oh, what's going on there? Okay. You don't need to see that now, but what I'm going to do is I'm going to label the diagram with some letters. I'm going to call this distance from A to the tightrope walker, if you want to draw a little tightrope walker, you can, is X, and this is Y. Okay? We know that this distance is going to be a total of 100. And now you're going to see this diagram blown up a little larger on the next screen, and I'm going to label this again, and then we're going to answer question A. Okay, so here we go. What's that line doing there? That's for later. That shouldn't be there now. Okay, so we have this is 100. This is my X, and this is my Y. Part A, how fast is the shadow of the tight walker's feet, that's right here, moving along the ground when she is midway between the buildings. Midway between the buildings means the tightrope walker is right there. So now I can bring that line back, right? Oh, I forgot I can't just do that. So let's bring that line back now. Here it is, midway between. That's right there. Say we'll be pretty close. So that means for part A, we know that dx dt in our dreads, our rates, our dx dt, the tightrope walker is walking at 2 feet per second. And right now we're looking at dy dt. We're looking for dy dt. What is dy dt? What is this? When x is 25, because it's midway, right? Midway. So right here would be 25 feet. Great. So again, using that idea of similar triangles, we're going to set up a proportion. So if you think you can do it, pause the video now, try to set it up, and then come back and check. I'm going to continue moving, but I'm going to give you these little indications to pause it. See if you can work it out, because that's where you're going to learn from your mistakes or confirm your understanding of the material. So we have y over 100. How do we have y over 100? This is my y distance, okay, over this. So it's this side of the triangle to this side of the triangle, and that has to be equal to this side of this triangle, the similar triangle, to this. Well, that's easy. The bottom's going to be 70, but what's this going to be right here? What's that going to be? Well, we're going to call it x because it is not a constant. It is changing. It is changing, so I'm not going to put 25 in there like some of you may think. It's when this is happening, but it is still changing. So now we have our diagram, we have our rates, we have our equation. So now we're going to derivative. So let's take our derivative. So since we're taking it with respect to t, we know this is going to be dy dt. Whoops, what did I forget? Yep, 1 over 100 times dy dt equals 1/70th dx dt. Alright, I'm going to move it a little bit faster along now because I'm running out of time and YouTube only let me upload some videos. So here we have, what do we have? We have dx dt. So we can plug in dx dt. We're looking for dy dt. So you can do the math, substitute and solve from there. And when you do the substitute and solve, you may have hopefully already gotten that shadow, that dy dt, ends up being 20 over 7 feet per second as your final result, your answer. Okay? Now try part B, and then move on and check it with the video. So here's part B. Part B says, how far from point A is the tightrope walker when the shadow of her feet reaches the base of the building, of the opposing building? Indicate units of measure. So now we're looking for when this shadow is here at C. So, we got to remember that. So when that is there. So let's look at this. We're going to use a similar proportion. But this time we're going to talk about x. That's going to be this distance. Now remember, our new situation has a line here. That the line, and let me see if I can make it a different color. Maybe I need to go over there and say this is when the line, there you go, is right here. So we have our x. We're going to do a different proportion here, but same idea of similar triangles. X, okay, is to 50 as 70 is to 100. And that's where, again, x is to 50. Okay, so corresponding sides. 70 is to 100. And it looks something like this. X over 50 equals 70 over 100. Okay? And it's not asking for any types of rates of change or anything. It's just asking for what that distance is. So we just have to solve for x. Solving for x, you get x equals 35 feet. All right? Easy sneezy, lemon squeezy. So, part C. So pause it, try it, then come back and check. How fast is the shadow of the tightwalker's feet moving up the wall of that building when she is 10 feet from point B? So now we're talking, and I'm going to try to do this. Let me see if I can adjust this. Okay, here we go. So now we're talking about this guy. Oh, that's not letting me change it. So let me delete it, and we'll put a new line there. There you go. I feel like I'm Bob Ross. Pretty little clouds. Here's a nice little line. Here we go. So now we're walking up. Now we're looking at the shadow going up. So we have to identify a new variable, and we're going to call it z. So there's my new variable. So here we have x now here when it's 10 feet from B. So we know, here we go. So what is this going to be? Whatever this is going to be 50 minus whatever's left, which is the x here. So that's this distance right here of this little line. So we're going to do the same idea. We're going to set up A. We still have similar triangles. AA, this A, and this A, meaning angles. They are congruent because of vertical angles. And then the right angles. They're both right triangles. Okay, so here we go. Moving right along, we have Z is to 70, which is this side of this triangle, is 50 minus x is to x, to this triangle. So we're looking at these this big triangle right here and this little guy. Okay? So moving right along, that is our proportion. So you can go back and look at this once I write it down, and you can kind of figure out its corresponding sides. Now what I'm going to do is I'm going to do my thing. I'm going to take the derivative and do my thing. So I'm going to let you take some time to do that. I'm going to keep on moving. But again, pause the video. Alright. Oh gosh, you're going to do low times the derivative of the high minus high times the derivative of the low, which is just 1 all over low, low. So you're going to get this. We simplify that, and we get what? Negative x minus 50 plus x. And it looks like my x's go goodbye-bye. And I'm left with 1/70th dz dt equals this derivative, which is end up being negative 50 over x squared. Oh my goodness, what did I forget? uv prime, we have some dx dt's here, right? Oops, I forgot my dx dt's. So u low, t high. So there's a dx dt in here. Thank you if you caught that. We have a dx dt, and then high d low. That still has a dx dt there as well. So this whole thing, since there's one dx dt in both portions of it, we can just multiply it outside by the dx dt, and then we substitute and solve. So you may have to find x. We know it's when it's 10 feet from part B, so if the whole thing was 50, we know x is going to be 40. So we're looking for dz dt. We have this. I'm going to pretty it up, and then I'm going to let you finish it and then just give you the answer. Ends up being negative 50 over x squared dx dt. And if you solve this correctly and find all the right things, this is an x, this is a t, you end up getting dz dt as equal to 35 over 8 feet per second. That is your solution for part C. And that's after you just substitute and solve. Well, I hope you enjoyed this video, and this is 91AB6. And again, take your opportunity to pause it, work out the problem, and then come back and check the solution. Johnstone out.